Assalamualaikum and hi to my viewer. Today, us from Group 2 of Introduction to Automotive Industry will be talking about today's technology that will be inserted in the electric vehicle of cars today, which is fuel cell. Here, our group consists of 4 people. Firstly, goes to me, which is me, goes by the name of AZAFIKA bin KHAIRUDDIN. Secondly, goes to Muhammad IRFAN HANIS bin ROSLAN. Third is Muhammad AZIM bin KAHAR NORDIN. And our last group member is Muhammad Amirul Farhan bin SYUKUR. Right, for this session, I'm going to talk about what is hydrogen fuel cell vehicle. Right, fuel cell vehicle is simply said is basically is just a hydrogen car that runs on hydrogen gas. Okay, it sounds complicated, but how do they work compared to ICE? So basically, fuel cell cars are powered by compress the hydrogen gas that feeds into an onboard fuel cell stack that doesn't burn the gas, but instead it transforms the fuel cell chemical energy into electrical energy, just as shown in the slide here. Right. After that, it brings the electricity, then powers the car's electric motors. The tailpipe emission are zero, so it's very carbon emission friendly, and the only waste produced is pure water. Okay, so how does this fuel cell works anyway? Well, it's very simple. The construction of the fuel cell is similar to a battery. Hydrogen enters the anode, where it comes in contact with a catalyst that promotes the separation of hydrogen atom into an electron and proton. As you can see here in the diagram that I've shown here, is the example of how a fuel cell looks. The electrons are gathered by the conductive current collector, which is connected to the car's high voltage circuitry, feeding the onboard battery and all the motors that turn the wheel. That means the electricity that is got from the fuel cell is distributed all inside the car, which is required the electricity that have been provided by the fuel cell. That's all for me. I'll be passing on the next slide to my next group member.
Alright, next I will talk about the development of fuel cell. Alright, firstly, yearly research 19th to mid-20th century. 1839, Sir William Grove discovered the principle of the fuel cell, laying the groundwork for the future development. Next, initial experiment demonstrate the conversion of chemical energy directly into the electricity through the electrochemical reaction. Next, commercialization and application late 20th century. Late 20th century see the commercialization of the fuel cell for niche applications such as backup power, system of telecommunication tower, and remote location. Next, company like Ballard Power System and UTC Power invest in fuel cell technology for various applications, including the transportation and stationary power generation. After that, advancement in material and efficiency, late 20 to early 21st century. This is to research and development effort focus on improving the efficiency, durability, and cost effectiveness of fuel cell. Next, proton exchange membrane fuel cell become to the most widely deployed type, especially in automotive application due to their high power density and relative low operating temperature. After that, hydrogen infrastructure development 21st century. Government and private sector entities invest in building hydrogen infrastructure, including hydrogen production, storage, and distribution facilities. Next, fuel cell vehicles such as the Toyota Mirai and Hyundai Nexo are the introduced. Albeit with the limited market penetration due to the infrastructure challenge and high cost. The last one, the renew focus on the clean energy present with growing concern about the climate and change and air pollution. Fuel cell gain the renewed attention as a clean energy technology. Next, ongoing the research effort new the material, catalyst, and the system design to the enhance the performance and reduce the cost of fuel cell technology. The last one is a collaboration effort between government, industry, and academia aim to accelerate the adoption of fuel cell across the various sector. including transportation, stationary power generation, and the portable electronic.
Okay, now turn me to explain about recent development in the use of fuel cell in Malaysia. Okay, first, fuel cell opportunities in Malaysia. Despite the challenge, there are also a number of opportunities for fuel cell in Malaysia. The Malaysian government is committed to developing fuel cell technology and has launched a number of initiatives to support the industry. This includes the National Hydrogen Roadmap, which outlined a strategy for developing and promoting the hydrogen economy in Malaysia. The government has also provided funding for research and development into fuel cell technology. In addition to government support, there is also a growing private sector interest in fuel cell. A number of companies are investing in research and development of fuel cell technology, and there are a number of fuel cell projects underway in Malaysia. Finally, there is a growing public awareness of the need for clean energy and the potential of fuel cell to help address climate change. This is creating a strong demand for fuel cell technology. For example, the state of Sarawak has shown a high commitment to developing a green economy by giving a special emphasis to hydrogen technology. Sarawak is trying to be a leader in the use of hydrogen as an alternative energy, including in the transport and energy sector. Alright. Okay, now we go to advantages of fuel cell. Alright, fuel cell offers several advantages over traditional energy source. They are environmentally friendly because they do not produce greenhouse gas emission or other air pollutant. They are also efficient, meaning that they can convert more of the fuel energy into electricity than traditional combustion engine. Okay, this makes them a more sustainable way to generate electricity. Okay, fuel cells are also versatile and can be used in a variety of applications, making them a potentially valuable tool for reducing our reliance on fossil fuel. Alright. Okay, for the next station is fuel cell challenges in Malaysia. Okay. Despite the many benefits of fuel cell, there are still some challenges that need to be addressed before they can be widely adopted in Malaysia. One challenge is the lack of infrastructure for hydrogen and fuel cell. There are currently very few hydrogen refueling stations in Malaysia, and this makes it difficult for fuel cell vehicles to be adopted on a large scale. Another challenge is the cost of fuel cell technology. Fuel cells are still relatively expensive, which make them unaffordable for many consumers. And finally, there is a need for supportive government policies to encourage the development and adoption of fuel cell. This includes policies that provide financial incentive for research and development, as well as policies that promote the deployment of fuel cell vehicle and infrastructure. Alright.
Okay, next is the research and development goals. First of all is the cost. The cost can research, development and demonstration. RD&D focus on the development of low-cost fuel cell stacks and balance of the plant BOP component and advanced high-volume manufacturing approach to reduce overall system costs. The second one is the performance. The performance to improve fuel cell efficiency and performance. RD&D focus on the innovative material and integration strategies. Efforts include developing ions exchange membrane electrolyte with exchange efficiency and durability at reduced cost. And the last one is the durability. Fuel cell application generally require adequate performance to be maintained over long period of the time. The OE has been set ultimate target for fuel cell system lifetime under realistic operation condition at 8,000 hours for lighting duty for vehicle, 30,000 hours for heavy duty truck, and for the last one is the 18 hours for the distribute power system. That's all from us. Thanks for watching. With love from Group 2.